Welcome back to another edition of Who Wants to Be a Mathematician. I'm your host, Mr. Hill, coming at you with the second part, part 2 of applications of triangles. So if you didn't look at first part, go back. There's another video, so check this one out. So we're going to start off this video with an example that you should do. So pause the video, take a second, look at this problem, try to figure out, work through both of them, A and B, and come on back after you've done that. So pause me if you haven't paused me by now. You should have, because I'm diving right into the circus tent. So here we go. The circus has arrived. Needs to put a main tent on brown field. The side is 40 feet above the ground. That's crazy. 40 feet up. Do you know how tall that is? That's like 5 stories. Each story is about 8 feet. I guess it's more like 4 stories because not only do they have, I don't know, joists and all the stuff that they need to put floors up. So 8 feet for the height of a floor, and then I guess you could say another 2 feet for... Anyways, so the rope is tied from the side of the tent to a stake in the ground. If the angle that the rope makes with the level ground is 50 degrees, how long is the rope? So level ground is down here. The rope and the level ground make an angle of 50 degrees. So if we draw our triangle a little bit bigger and nicer, we got, this is 40, what is this? This is 40 feet, and this is going to be 50 degrees. We're looking for x. How they're related, this is our opposite side, this is our hypotenuse. So we know sine of 50 is equal to 40 over x. So doing some algebra, we get x times sine of 50 is equal to 40. X is equal to 40 divided by sine of 50. Pull out your handy dandy calculator. We have 40 divided by sine of 50. What do we get? And I get the length x. X is equal to 52.22 feet. That's how long the rope is, 52 feet. So a stunt man is standing at the top of the tent and looks down at a Brewster student who is 100 feet away from the stunt man. What is the angle of depression? So again, I like colors, and I kind of like the black background, so we'll go over here. So we have our tent with our crazy colored sides, because it's a circus, and who knows what goes on at that circus. So there's a guy standing on top of the tent, and he's looking down at the Brewster student who is 100 feet away. So 100 feet is between the two people. So between the Brewster student and the guy is 100 feet. We still know the circus tent is 40 feet tall. And we're looking, what is the angle of depression? So if we draw a triangle, we have 100, we have 40. And we know this right here is what we're looking for. Well, to find this angle, we need to find that angle. So if we redraw our triangle once again, we need to find this theta, 40, and 100. So we know theta is related by, this is adjacent, this is hypotenuse, so adjacent over hypotenuse, and that is by cosine. So cosine of theta is equal to adjacent, which is 40, over hypotenuse, which is 100. And to find this, we're going to take the inverse of both sides. So cosine inverse of cosine theta is equal to cosine inverse of 4/10. I just did some, got rid of a 0 there. So these cosines cancel out. We have theta is equal to cosine inverse of 2/5. Did another cancellation there. So pull out your calculator. Cosine inverse of 2 divided by 5. And I get theta is equal to 66.42. Well, I'm not quite done yet, because that is this angle. And I really want this other angle over here. I want that angle. So what do we know? We know that 90 minus our 66.42 is going to give us what we want. So if we do this math out, we have 20 gives us 8, so this would be 23.5 23.58. The angle of depression is 23.58 degrees. Bada bing, bada boom, and you're done. Let's look at something else. This is going to get crazy. Be ready, because here we go. A regular polygon is inscribed in a circle with a diameter of 8.34. The apothem of a regular polygon is the measure of a line segment from the center to the midpoint of one of its sides. So that right there is an apothem. We want to find the apothem of the polygon. So a couple things going on. One is we know inside of this we have this lovely polygon, also known as a pentagon. And we know that we're trying to find this here apothem. Well, we've been dealing with right triangles for pretty much the past couple days, so let's try to create a right triangle. So if we go from the center all the way up to one of these corners, we know we have a right triangle there. So if you think of a pizza or a pie, whatever you want, that kind of looks like a pizza slice. Well, how many pizza slices does our pie have? If we do our apothems into all the corners, how many pizza slices does that create? So if we duplicate our apothem pie, if we duplicate that pie right there, how many slices do we have? Well, let's count them. A 1, a 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 slices. And how many degrees is one of these here circles? We know a circle is 365 degrees, and each slice is a tenth of that. So that gives us 36 degrees per slice. 36 degrees per slice. So now if we come to our triangle up here, we know 36 degrees is our angle right there. So now we just need to figure out a side, and we can figure out the length because we have trigonometry. So we now need to look at another circle that has our wonderful pentagon inscribed in here again. And what does the problem state? Oh, well, the problem states that we have a diameter. So if we go from one point to another, we have a diameter of 8.34 centimeters. Well, if we look at our triangle up here, it kind of looks like this side right here is one of the sides of the triangle. And we notice that this side is half of our diameter. So we could label this 4.17. So now we have the triangle that we need. If we redraw this, so bring this triangle out there, we have 36 degrees, we have 4.17 as a side, and we're looking for our apothem. So we're looking for this side of our triangle, this side right here, the one that's getting really, really dark. So now we need to relate. We have an angle of 36, and we're relating it to our adjacent over a hypotenuse, so that's going to be our cosine. So cosine of 36 is equal to our adjacent, and our adjacent was our x, and our hypotenuse was 4.17. So now we just need to do some multiply both sides by 4.17 times cosine of 36, and we're going to get our x. So x is equal to 4.17 times cosine of 36. Bada bing, bada boom. 3.37. And what type of unit do we have here? We have centimeters. Notice the centimeters. Make sure you add that in. Centimeters. Bada bing, bada boom, and we're good to go. So you got one more guided practice on this, but I'm going to let you do that on your own, and you can check back in with me when you get back. So thanks for watching. Have a great weekend.